Now we have another question on factorization of quadratic expression. Question 4. What to factorize is 10 minus x squared minus 3x. Now in this kind of question, the one we have been familiar with is that the x squared is meant to come first, but this time around, it was arranged in a way that the x squared is at the middle. It's left for you to rearrange. You can rearrange this expression to make it look like minus x squared minus 3x plus 10. This is the same thing as this. They are the same thing. So then you follow the same format, the same method. That is, the coefficient of x squared here is minus 1. You multiply it with the last term. This times this. 10 plus 10 multiply minus 10 minus 1. That will give us minus 10. Then minus 3. Now, you now think of two numbers that when you multiply them, you get minus 10. And when you add them together, you get minus 3. You think of two numbers that when you multiply them, you get minus 10. And when you add them, you get minus 3. The numbers are minus 5 and plus 2. Because by the time you multiply them, minus 5 times plus 2 give us minus 10. And by the time you add them, minus 5 plus 2 give us minus 3. So the factors are minus 5 and plus 2. We now come back to the equation now. We now come back. Now say minus x squared. Instead of saying minus 3x, so minus 5x and plus 2x. We now replace that. Then plus 10. Minus 5x plus 2 has replaced minus 3x. Minus x squared remains the same, plus 10 remains the same. Just that the two factors has replaced minus 3x. Now, between these two, something is common. X is common between x and 5. So we can bring it outside. If you bring minus x outside, what this means is that you're only going to be left with an x here, then this sign becomes plus, and here you'll be left with 5. If minus x is common, you bring it out. Since this is negative, you bring negative out, it's going to affect this sign, the sign becomes plus. So by the time you expand, you get the same value back. Plus, between 2x and 10, 2 is common. So bring 2 outside, so you'll be left with an x plus 2 in 10, 5. Now, we now have x plus 5 on both sides. It now becomes x plus 5. You pick one, since there are 2, and minus x plus 2. Minus x plus 2. In which this can still be rearranged. That means we can have x plus 5 and 2 minus x. You can leave it like this or like this. And that is the end of this. So this has been factorized as x plus 5 and 2 minus x. Now let's come back to this. We want to look at how we can factorize the root of two squares. That is, when you have two numbers that you can easily have a perfect square. Now, we have a square minus b square. This is just to illustrate what we mean by difference of two squares. This will finally give us a plus b and a minus b. By the time you expand this, you are going to get this back. By the time you expand this, you get this back. So this will be the theorem that will be used in that root of two squares by method of comparing. Now, for example, let's look at this. We have x squared minus 25. X squared minus 25 can be written as 5 raised to the power 2. That is 5 times 5. 5 times 5 will give us 25. If you now compare this with this, we can see that instead of a, we now have x. And instead of b, we now have 5. It means this can, following this expansion, is going to become x plus 5 and x minus 5. Instead of saying a plus b and a minus b, we now have to be x plus 5 and x minus 5. So this is the factorization of what? X squared minus 25. That's what we call difference of two squares. So in our subsequent class, we'll be looking at another examples on difference of two squares. Thank you.